Hola, buenas tardes a todos. ¿Cómo están ustedes? ¿Cómo están ustedes? ¿Bien? Me llamo Michael Fisher, y eso es el todo español que yo sé. So, testing one, two, three. Oh, no, no, there's no sound. There are no speakers. It's for the, sí, 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 sí. ¿Ustedes listo? Okay, voy a comenzar. Um, so my name is Michael Fisher. I'm here today. I'm here from. Gracias. Okay. So my name is Michael Fisher. I work for AWS. Have you all heard of AWS? Raise your hand. Okay. My title is Principal Specialist. I work on Amazon EC2 virtual compute, and in particular Graviton. Has anybody heard of Graviton? Oh, good. Okay, cool. Next. So in my talk today, it's going to be pretty short, just a half hour. And at first, we're going to talk about the fact that today, it's not just about x86 CPUs anymore, the processors. There's a diverse and growing market of CPUs that you can take advantage of, and your companies can take advantage of. And I'll talk a little bit about the history of that. I'll also talk about why you and your teams and your companies should care about this. Why does it matter? Because people have been using Intel for decades, and if is there a reason to switch? And I'll try to convince you that there is. And as a matter of fact, it's not just AWS that's using new technology. I'll talk to you about other companies that have been very successful with it too. And then finally, I'll give you a little background on how you can actually experiment and begin to move your workloads into production. Okay. Okay. So you've probably heard of a Raspberry Pi. Have any of you used one of those? It's it's a very small computer, but very powerful. It has up to 4 gigabytes of memory. It has multiple processor cores. It has onboard networking, onboard Wi-Fi. All you have to do is plug a little SD card, in with the operating system, and people are using it for all sorts of hobbies. And this runs on the ARM processor. Of course, it's not the first thing, but it is a general purpose computer. And the phones, those teléfonos in our pockets all use ARM processors too. How many of you have a Mac or want a Mac? How many have you heard about the M1? See, M1. It's an ARM-based processor, very fast, very cool, runs very low temperature. It's an amazing, marvelous piece of technology. And then I asked earlier about Graviton. Graviton, for example, is AWS's first family of instance types that uses this advanced architecture as well. So just a quick brief history on where we've been, and the fact that having different kinds of processors is not new. It's been happening for decades. So we started way back in the 1960s with enormous mainframes, right? They occupied entire floors, entire rooms, and those used processors like the Z80 or S370, very old, some of the first microchips that were invented. And then in the 1980s and 1990s, we started to see personal computing. So when I'm showing my age a little bit here, soy viaje, pero Commodore 64, IBM PC, Apple computer, the beige boxes. So those used early, they used 6 Motorola 8-bit processors, and then we moved on to 16-bit. And then in Apple, early Macintoshes used the Motorola processors. And then in the 1990s, We had workstations. Has anybody heard of a Sun workstation or Spark or Alpha? Um, these were the machines that powered the early internet in the 1990s when we had Yahoo and Alta Vista and AOL Instant Messenger. You see, those were all powered by those kind of servers. And then in the early 2000s, we went from 32-bit Intel, which was everybody's Windows PC, like Windows 98, Windows 3.11. You'll all remember those. So those were based on 32-bit Intel, and then AMD invented an extension, a 64-bit extension to those processors called AMD 64, and it was so popular that Intel adopted it. And so that's why sometimes on your computers, if you type like uname-m, you'll find AMD 64, not x86. It's historical. Okay, and then starting in the 2010s, Apple introduced the iPhone, and Motorola, Samsung, that they introduced Android, and those all began to run on ARM processors. And ARM technology was invented in England in cooperation with the BBC, actually, the British Broadcasting Corporation, as an experiment in building their own processors, and it became very popular. Why? Because they're very low power. They're very conscious about energy use, but also very fast. And so what happened was it became so popular that people started to ask, can we do more with this? Can we use this not just for embedded devices like in your phones, but also in our real computers? And the answer is yes, we know this now, because we have the Mac M1, we have Raspberry Pi, and there's more, and now it's in the cloud. Okay, so a little bit of history. Why should we actually adopt a new CPU architecture? Why should we even try this? Everybody, how many of you are all running on Intel today in the cloud or AMD? Do you know? See, okay. So why try it? Oh, 3 reasons. Number 1, performance. The newest ARM-based processors are significantly faster. Number 2, cost. Because they're less expensive to operate in the cloud. They cost less per hour. And then sustainability, because they use less energy as well. And I'll go into this a little bit in the next slide. So first, let's talk about performance. So in terms of performance, we have researched, and we've learned that ARM64 instances are up to 30% faster than the comparable Intel-based or AMD-based instances. And why is that? Well, several reasons. Number 1 is that these are built with a more advanced manufacturing process. There is lots of innovation among chip makers, chip designers, and especially in Taiwan. The same company that actually makes the chips for Apple also makes chips for the cloud as well. And so they've done a fantastic job of making the chips and the circuitry smaller and smaller and smaller. So today it's down to 5 nanometers. That's super, super, super tiny. And it's a very advanced manufacturing process. The second reason is that the design is much simpler. So Intel CPUs have a lot of circuitry in them that is used for backward compatibility, so that you can run very, very, very old software, like 20, 30 years old, on an Intel processor today. And while that is important for some people, it's not very important in the cloud, because people in the cloud don't need that kind of backward compatibility. And so chip designers are able to remove a lot of the circuitry that was put in there in order to make the chips faster and less complicated. And a less complicated processor is smaller, uses less energy, and is faster. In addition, the ARM processors do not have hyperthreading. Has anybody heard of hyperthreading? So hyperthreading is where you have one real CPU core, but to the operating system, it looks like two CPU cores. But the extra CPU core is fake. It's not real. It's simulated. And a simulated CPU core does not run as fast as a real CPU core. But with ARM processors in the cloud, you get every core is a real core. And also the other one is that these processors have what's called a full mesh architecture. What does that mean? That means that every core in the processor inside is able to access equally all the memory available in the system, and there's no penalty by having different CPUs access different areas of memory. There's no extra latency. So it's very, very fast. And then in terms of cost, they are less expensive than x86. That is because of the diversity of different devices and chips available for different makers. So for example, when Apple built the M1 processor, it did not own the technology for the processor. A company called ARM had that. And Apple was able to take ARM's or license ARM's inventions and go to the chip maker and say, I want a chip that does exactly this with these performance characteristics, and it was all customized. So everyone who uses these in the cloud is able to customize them specifically for their customers. And also, there's this idea of economy of scale. These manufacturers can build these chips at less expense because they build so many of them. And because they're simpler, they're less costly to produce. And then when the cloud providers like AWS, GCP, Microsoft Azure, if they want to adopt this technology, they can customize it specifically for their own customers. So Amazon, for example, built Graviton, which is customized for AWS EC2, and every company that does this can do the same. All right, and then next is sustainability. How many of you care about sustainability, about being green, using less energy, making less pollution? I know I do. And so these new instance types, these new CPUs, they can do for every unit of energy, for every watt they consume, they can do 3 times as much work. That's huge. That's incredible. And as a consequence, not only that, but the inverse of that is that they use less energy. And when you use less energy, there are a few consequences of this. Number one is that you can install more computers in the same cabinet, in the same rack. So that means, and when you can install more in the same rack, it means you use less real estate, less floor space, right? So instead of a huge room, you can have a smaller room, right? And if you have less real estate, less floor space, it means you have less to cool, less air conditioning, right? All of this is, it adds to the energy savings overall. Oh, lo siento. And so every cloud provider, AWS, Google, Microsoft, I researched every company, and they all said that sustainability was extremely important to them. And how many of you have heard of the Amazon Climate Pledge? You know about this, the Climate Pledge. So the Climate Pledge, Amazon is going carbon neutral by the year 2040. And all cloud providers are doing this. Google's doing it, Microsoft's doing it. And we also know that a lot of the companies that you work for are also doing it. Are any of your companies have these sorts of climate plans, reduction plans, anything like that? So next I wanted to talk about the fact that this is not, although the technology is new, it's becoming very popular very quickly. And there are companies in all areas, in all businesses that are beginning to adopt it, and some have done it very, very quickly. So social media, like Snap, have you heard of Snapchat? Anybody use Snapchat? Okay, so Snapchat, for example, is one company that is adopting it very quickly. Finance. We have many customers that are in finance who are already adopting these new instance types. Crypto has also begun to adopt it as well, because these processors have special instructions which can be used to accelerate crypto processing as well. And these are customizations that cloud providers can make. Media and entertainment. We'll talk about some of the customers who are using it already there. And then, of course, chip designers themselves use ARM64 to build ARM64 chips. So it's a circle. Some of the customers that have already gained success here. How many of you have heard of Formula One, the race cars? So Formula One is using these today to improve the performance and lower the cost of what's called computational fluid dynamics. This is the simulation of how air flows around a vehicle, because in racing, reducing friction and drag is extremely important, right? And so they need to run simulations on new designs over and over and over again. Honeycomb.io is a startup you may have heard of. They do observability. They consume logs and consume metrics from your applications and allow you to analyze the performance of your applications at a very fine-grained level, sub-second level, below second level metrics, or sorry, resolution. Honeycomb has completely migrated. They turned off their last x86 instance a few months ago, and they actually saved 40%. They took 40% off their bill by switching to Graviton. And they also reduced their instance count, fewer instances, 30% fewer, just by switching. And then Snap recently migrated their entire messaging core to Graviton as well. And by doing so, they're actually planning to migrate the rest of Snap to this new processor architecture. So very powerful, very popular, very quickly. And today, it's available everywhere. It's available in AWS, in EC2. If you're in AWS, you can use Graviton for your instances, your EC2 instances. We have C6G, M6G, R6G instance types. And also recently we announced the C7G, which is even more advanced. And it's called Graviton 3, and that's available now. If you are in Azure, Microsoft recently announced these two new instance types that are in preview. If you are using Google Cloud, just 2 weeks ago, they announced the Tau 2A or 2A series of instance types, which are also now in preview. And then finally, if you are using Oracle Cloud infrastructure, they too also have these ARM64 instance types. Next, let's talk about how to migrate. I mean, it's great that these exist, but now the question is, how do you adopt them? How do you migrate successfully and with care? There are basically 5 major steps. Number 1, identify and prioritize the workloads. Number 2, update your DevOps pipelines, and I'll show you in more detail how to do that. Third, test, very important. And then begin your deployments. And then after everything has been transitioned, you can finally begin to retire your old x86 infrastructure. So I'm going to spend a little bit of focus on this because it's probably the most interesting part of my talk to you who are doing DevOps work today, and what this looks like. So basically, this looks like a typical DevOps deployment pipeline. Does this make sense to everybody? Like what this looks like? So you start with pushing code to a code repository, and then an automated process then begins to build the artifact, the software. And if you're using containers, for example, you might use a container build infrastructure in order to do that. And then once it's been built, then it's you have your test automation, and then finally You create, if you're using containers, you create what's called a multi-architecture manifest, and then finally you deploy. And you can use any pipeline, any sort of CI/CD DevOps system you want. I've listed many at the bottom of the slide. It doesn't really matter. The idea here is that upon code push, you begin to do both your builds and your testing, both building and automated testing on both x86, just like you're doing today, and also on ARM in parallel. And if you do it in parallel, it means that it doesn't take any longer, the process, as long as you're using native, the actual hardware, and not trying to do like software emulation or something like that, which you can do. I wanted to say that in terms of build infrastructure for ARM64, you have many choices. So you can, if you want, you can use the Raspberry Pis you have at home. Probably not for your business, but it is an option. You can use EC2 Graviton for your build and test. If you're using AWS, also Code Build, the AWS Code Build service also supports ARM64 already. And other cloud providers will almost certainly be rolling out support for this in the very near future. As a matter of fact, I'm working right now with GitLab on enabling ARM64 support for GitLab. And GitHub is coming soon. So the idea is to do that build and test in parallel, and then finally deploy to the correct infrastructure using whichever build is appropriate for it. So I want to make an important point about testing. So it's important to invest in the automation of testing if you have not done so already, because otherwise this can be a very costly and time-consuming process. How many of you are already using automated tests in your DevOps pipelines? Okay. Well, I cannot emphasize enough the importance of automated testing. Every build, every push, because it's going to be because otherwise you're going to have people who now have twice the amount of work that they had to do before to be able to migrate and adopt, and that would be quite costly and time consuming. So I think it's we're all here, we're all DevOps practitioners. We're all here to advocate for that and build it ourselves. Now, in terms of once you've tested it, I wanted to talk about the strategy for deployment and actually doing the transition to ARM64. So the first step is to begin with your lower environments, your testing environment, your QA environment. I know many of you have those already. Hopefully you're not deploying straight into production. I know some people are, but obviously we all know that's not the best practice. So start with your lower environments and get comfortable deploying there and doing tests. And it's important to maintain x86 based lower environments like dev and test until production has fully migrated. And then once you are ready to actually begin production deployment, you'll want to adopt a canary strategy or a blue-green strategy to make sure to test it with your customers and make sure that everything is working as expected. And then once you're satisfied with that, then you can finally begin to retire those older x86 production stacks. But I wanted to point out that not to do this, because this is very dangerous. Muy peligroso. You never want to actually skip the testing part on x86 for as long as you have x86 in production. I don't suggest creating an ARM-based test environment and then skipping testing in x86 and deploying straight to x86, because it's very dangerous. So do this with extreme caution. I recommend always keeping that x86 test environment around. So when is it time to start? The time to start is now. I encourage you all to get started. I'm going to be here the rest of the day to talk to you about this. I'm more than happy to answer any questions. Even in Spanish, I will do my best. But I wanted to encourage you, and hopefully we'll see you start doing this and saving money, saving energy, being more better stewards of the planet, and overall enjoying the better performance as well. Thank you very much. Let's see. I have a couple of minutes for questions. Yes. 70,000. Oh, okay. So you're running 70,000 builds per day? Per week today. Okay. Yes. There was a slide that I had here, and I don't know if it went away, or see if I can find it for you. Oh, well, that's a shame. Okay, I'll talk about it. Okay, so there are three categories of software that to analyze. The first is software where it's written in a pure scripting language, like Python, Node.js, PHP, Perl, Ruby. Yes, Ruby. Can't forget my Rubyist friends. And those typically are easy to migrate because the runtimes, like the scripting host, are all available for ARM64 already. For example, if you go to Docker Hub, if you're using containers, you'll find a Ruby or a Python, many different base images, all of which have ARM64 support already. So, but that if it's a pure scripting language. If your scripting language has extensions like shared libraries that are written in C, for example, if they're open source, often they are often ready to be used on ARM64. There's not much trouble doing compilation on ARM64. The second category is Java. Java is also often very easy to migrate. In many cases, you can take an existing jar, even if you compiled it on Intel, and you can put it on an ARM64 server, and it will just work because the Java runtime environment is already there. But again, with Java, if you're using JNI, which is the native interface, then those native interfaces, those native shared libraries also have to be recompiled. So it depends. And then finally, there's the software that's written purely in C or C++. There are a couple ways you can do it. You can, there's much software that does not need any modification to run on ARM. You just need to recompile it. And sometimes there's software that is more difficult. My recommendation is that you identify the easiest workloads to move first, written in a pure scripting language, or maybe, so I would start there. And then, so I'd start from two directions. On one direction, you have the very low risk, easy to migrate, but maybe low impact because it doesn't use that many CPU resources. Maybe it's like a small application that doesn't get a lot of traffic or something like that. And then on the opposite side, I recommend finding a workload that's very high impact, it's very expensive to operate, and where you'll see a lot of savings by migrating that you can take to your bosses and say, look, I saved us saved us many thousands of dollars or more by migrating. Does that answer your question? Okay. You had a question? Yes. You're welcome. Oh, then your questions are invalid. It's SMG state. Yes. Oh, yes. So the gentleman was asking about Fargate. How many of you are, okay. Oh, no more questions. Okay. How many of you are familiar with Fargate? Have you heard of Fargate? Okay. So Fargate is a serverless container runtime for for Amazon, for AWS. You can use Fargate with ECS or EKS, the Kubernetes. And so Fargate is supported today for ECS Fargate, if you're using ECS, and also for, it's actually supported in Lambda as well. You can actually run Lambda functions at 20% less cost per function invocation. Both Fargate and Lambda are priced 20% less than x86. So if you're using Lambda functions or Fargate today on ECS, EKS is coming soon. Does that answer your question? Okay. That's all the time we have. I have to finish up. Thank you all very much for attending. It was very good to see all of you. Muchas gracias. A todo.